Welcome to Love My Tool. Our MC again today is Mr. Tony Fortunato, our northernmost expert. And today he's going to be spending some time talking about Wireshark, which is the quintessential tool for network analysis and monitoring and baselining and all those wonderful things you should do in your network, but probably never do. So Tony, take it away. And by the way, I'm wearing the first ever European Wireshark shirt. So, which was, by the way, was full. They had several hundred people showed up, and apparently it was awesome. So
is the size shirt in Europe the same as the size of shirt in the U.S.?
I could never find a tag in here that told me what the shirt size was. So it fit me, so I'm not worried. You know,
shirt size smart guy.
Yeah, right. So you know what? Thanks to Sweet Janice for sending it to me. Mm-hmm. I probably have so many T-shirts now I could start a T-shirt shop. But
there you go.
These are very nice. These are hot. So cool.
All right.
Aren't you jealous?
Yeah, I'm so jealous. I've got my shirt.
It's only one thing I tell people all the time, and I'm sure you do too. Why don't we baseline? Even a fundamental baseline. And, you know, you have, quote, 7 layers. You got several applications. You got everything from the physical layer to the magical application layer. And Wireshark is a really, really great tool for baselining. And if you're really innovative, you can take Wireshark or T-Shark with Snort, and you can do some of your own pre-diagnostics. Set parameters inside of Snort to say, hey, if this application runs over 100 milliseconds, let me know. Mark it. Send me an obscene message. Text my phone. Whatever. You know, and you go around the country and train people. So, looking to you today to give us some innovative ideas on how to use Wireshark. That was created by Gerald Combs. Take it away, Tony.
All right. Thanks, Tim. So we were talking just before we went on air with Tim why people don't use Wireshark. And I kind of flipped it around and said, why don't people baseline? And a baseline to me is pretty well everything that we do. And I want to try to dispel some of those myths on why people don't baseline. The biggest one people say is they don't have time. And I was jokingly telling Tim, people have time to look up the best taco truck in town and spend 3 hours online, but yet they don't have time to capture 5-10 minutes worth of packets. And I'm telling you right now, to get comfortable with Wireshark, to get comfortable with protocol analysis, we're only looking a couple of minutes a day. So hopefully, in these 30 minutes, I'll show you enough about Wireshark and enough about protocol analysis that those can start to be your everyday skills. The problem is Wireshark is a tool. That's the problem. So like all tools, they do nothing just lying there. So I've got tools in the garage and they're not plugged in and they're not running right now because I don't need them. But when you need them and you don't have the skills, then you're in trouble. So this is meant to build skills. And that's what I tell everybody I run into with any tool that I teach people with. And that's hopefully that's the confidence we're going to get. So this whole 30 minutes is going to be just tips and tricks and all sorts of little things that we can look forward to when we use Wireshark. So first thing I'm going to do is I'm going to share my screen. And the first tip I have for you is in the top left corner of my screen here, I've got Wireshark. And I'm just going to go to properties for a moment. And this is going to sound so simple and so silly, but I do this all the time. You see a shortcut key here? Of course, this is Microsoft operating system, right, folks? So in here, under shortcut key, there is no shortcut by default. So if you want to create a shortcut, you just click in that field, literally press Control, Shift, and the letter you want to assign to the application. In my case, W for Wireshark, and bang, it'll start up. And that way, every time you want to start Wireshark, you're not fishing around in your folders and putting more stuff on your desktop. You know, anywhere you want to get Wireshark, just hit Control, Shift, W. I do the same thing with my command prompt. Control Shift C, my command prompt pops up. So something so simple, something so easy, and trust me, that makes it more available and you're more likely to use it. Later on, I'm going to also mention a little trick that you can use when you run Wireshark where it can start and commence a capture on whatever interface you want. All right, so that's number one. What I'm going to do right now is just go through a couple of slides just to set the framework, and then from there I'll jump right into the tool. Don't worry, it's not going to be a slide fest, folks. So this is kind of like what Tim was talking about a little while ago, right? The layers, and there are 7 layers in the OSI model, but I'm not going to argue that point. I like to use this 4 or 5 layer model, because to me that's where things work and you can actually relate to them a little bit better. And the physical layer at the bottom is the obviously cabling, electrical, light, radio. And the rule of thumb I tell people jokingly is if it can electrocute you, blind you, or strangle you, it's probably at the physical layer. The point here is, guess what? This has nothing to do with Wireshark. So when people try to troubleshoot layer 1 errors with the wrong tool, guess what? It didn't work well. So this is why, the only reason why I bring this up is because people sometimes use their favorite tool a little too much, right? And the comment I give people is use Wireshark to prop open doors and crack walnuts. Like, you need to understand when to apply the correct tool. So as you can see on the side here, I put cable tester or spectrum analyzer along the side, or light meter, or whatever kind of layer 1 tool that you need. So the protocol analyzer really starts to come into play when we have some sort of MAC address, some sort of frame, some sort of packet, however you want to say it, right? But just when we have a series of 1s and 0s or electrical or light impulses, that's the wrong tool for the job. All right? The only thing that you can do with Wireshark is when you have physical layer problems, you might see the effects of it. Drop packets, retransmissions. It's not going to show you exactly what happened, but that's the symptom of the problem. So why do we use Wireshark? Well, you want to determine how your applications behave on the wire. And this is becoming a big thing because more and more people install apps, and the apps kind of do things on the back end. Some apps are ad-driven, and where are those ads coming from and how much data is that? I downloaded an app on my Android phone, and within a week I had 20 more meg on my data plan than I used to have. And I tracked it right back to the only app I added. I did a quick capture on it, and guess what? The ads were just nonstop and sucking up the data. So I canned that application. You can identify application dependencies. I may just do a whole separate session on this. Mike Canny talked about this the other day, of application dependencies, and there isn't a lot of documentation on it, so I may just take that as a separate one altogether. If you got to configure firewalls, oh, sorry, Tim.
I was going to say that's a priority. If you don't know, it's like I asked a guy one time, give me a dependencies block or chart, and he said, I don't know. I said, well, let's look on your switch, and on one port on his switch, he had something like 8,400 IP addresses, which was about 85% of the company IP addresses. And I'm like, that's probably overloading that one port. That's probably not doing what a switch is supposed to do,
Maybe.
Yeah, maybe we need to change that. And, and that's a dependency that you need to have. You need to know what's going on and who does what in your network. Or, as you mentioned before, guessing is not good when you're trying to find out what a problem is, or trying to find out if you've been attacked like your friend did today. So,
yeah, right. And a dependency analysis comes with physical layer, application layer, and all sorts of stuff. So again, I think that's a great topic for another session. Assistance in configuring firewalls. If you need to know the port number or some kind of application signature, typically use some kind of protocol analyzer. A lot of firewalls allow you to capture packets, right? Documenting, understanding why your application is slow. That's the #1 reason why I'm always asked to use it. People say it is slow, and I don't know what it is, and I don't know what slow is. So Wireshark helps define the 2 variables, right? To see if critical data is in clear text for security compliance, there's still a lot of applications with clear text. I was working at a customer site. They have a homegrown email program, and the credentials, when they log in, was not clear text. Yay! The full body of the email was, boo. So that sort of thing. Validate that your PC is configured optimally. Identify viruses, Trojan worms, other uninstalled software. Monitor your network for unwelcome applications like peer-to-peer apps. And then validate network component configuration and behavior. So switches, routers, firewalls, printers, webcams, the Internet of Things. Those things are yapping away. So it's kind of nice to be able to find out what they're doing. All right, next slide. So when we install Wireshark, just a quick note, you should be aware of the term WinPCAP. So WinPCAP is a piece of software that Wireshark uses to find out if you have Ethernet, if you have Wi-Fi, Bluetooth, whatever you consider a network adapter. Without WinPCAP, Wireshark won't find anything. So when you install it for the first time, depending on your operating system and your user access configuration, it may pop up and say, hey, you want WinPCAP to start up as a service next time? If you say no, the next time you reboot your machine, you're going to have a problem, right? So just be aware that we need WinPCAP. WinPCAP, that piece of software, as Tim said earlier, isn't just a Wireshark thing. Other applications, just like Snort, for example, would use WinPCAP as well. So it's not a Wireshark thing, okay? The other thing is, if you use USB adapters to capture packets, just a little note, I've done a lot of testing on them. Those timestamps, they're not accurate. And it's just the nature of USB. And if the goal of the exercise was to capture the packets just to see who you're talking with, great. But if you're trying to troubleshoot delay and latency with USB, you may have a problem, okay? Next slide. So capturing on wireless networks, and I get this question a lot. I have my Windows laptop, Wireshark, I capture the Wi-Fi packets, and I don't see any of the 802.11 stuff. I don't know what channel it is. I don't know what SSID it is, all that kind of stuff. Well, you're not, because Microsoft doesn't show you that stuff. Microsoft has an NDIS driver, and it filters all that nonsense out for you. So if you want to see all this stuff, you need a special card and a special driver, or try a different operating system such as Linux. And some of those drivers will let you see that natively, unlike Microsoft's, just so you know. When you install Wireshark on a machine, sometimes we do this, and you have to get a user to install it, right? And that can be very cumbersome if they don't understand what's going on. So you can actually install Wireshark from the command line in silent mode. And what that will do is silently install Wireshark and leave a desktop icon on the desktop when it's done. So the user doesn't have to click next, 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 and possibly make a mistake. So down here at the bottom, that's the actual syntax you can use from the command line, from wherever you have your setup program, obviously, and then it will install Wireshark for you silently. While you're installing it silently, if you want to check on it every once in a while, just go to your task manager in Windows, and it'll tell you that Wireshark setup's running. But you'll also know, because at the end you'll end up with a desktop icon, and you'll know that it's done as well. Okay? But if it's taken a while, you may want to just check up on it. This is something that Tim and I can spend probably 4 hours on, so I'm going to try to summarize this in 30 seconds or less. When you have switched networks, just be aware of what you're analyzing, how you're analyzing, and with what you're analyzing it with. So for example, if you're using a span or a monitor port, those physical level errors do not come across the port, right? They just don't, period, end of story. And I'm talking general rules, folks. You may have exceptions I don't know about, and that's fine. But I'm just talking general rules, like the 90 percentile. If you do have a tap, right, please make sure that obviously your machine can handle the data. Just because the tap sends it to you doesn't mean you can handle it. Chris Greer's written a few articles about this. I've written a few articles about this. Make sure you understand the tool and you don't overwhelm it. Down here in the bottom left corner, you can see there's a 100 meg link coming down, and there's a hub sitting there. Well, hubs are half duplex. So you might want to make sure all the devices are half duplex and the switch port is half duplex. Just make sure you don't cause a problem is what I'm saying. All right, folks? Analyzing routed networks. I wrote an article about this, and this is a pretty simple little trick. If all of these devices were going to the internet, and I want to capture all the internet traffic, the easiest way to do it is filter on the router's MAC address. And that way you'll have all the inbound and outbound internet stuff, and you will not see all the local stuff, printers, file servers, and that sort of thing. And the opposite applies, right? Not router's MAC address means you see all the local stuff. So a little bit about Wireshark. When you start it up and you go to Help and About, you're going to see a couple of tabs at the top. And the big one I like to use is the Folders tab. And people aren't even aware of this. When you go to the Folders tab, it shows you where Wireshark stores files, either filters, configuration files, that sort of thing. So that's really helpful to know. And all of these paths are blue for a reason. They're all links. If you click on one of the paths, it jumps to that folder. So now I can customize. D filter stands for display filters, and C filters would be obviously capture filters. They're all text files. So the nice thing about that is if you don't want to use Wireshark to create your filters, go ahead, create your own filters. Just keep one thing in mind, a little tip or a trick. When you create something manually with a text file, with a filter file, please make sure the last line in the file is blank. Okay? Otherwise, it'll ignore that last filter. That's all. And you'll notice that when you open it, the last line is always blank. We've talked about this already, the little shortcut that I showed you. And by the way, folks, I'll make this presentation available. I'll upload it and I'll just provide a link, okay? And that way everybody can go get this if they want. And if you did want to run Wireshark from the command prompt, you can actually find out your display, T-Shark-D, which stands for display all the interfaces, right? And that will dump out all the interfaces and give me a number and give me this big long string, okay? So you can use either one when you use T-Shark to capture from that interface. So if you wanted to, you can actually start Wireshark and point it to that interface and it will start capturing automatically, okay? But Wireshark-D will give you a list of all those interfaces. If we have time at the end, I'll bounce in and I'll show you how that works. So we start up Wireshark. There's our typical screen. The capture filter's here now. Things have changed in version 2 if you're not familiar with this. And of course it shows me all the adapters that it's finding. And it shows me the activity on each adapter as it's talking as well. If you go into your preferences, this is kind of important. You can always configure an adapter as your default. So for example, I have Ethernet killer gig. That's my default. So whenever I start Wireshark and I just hit start, it'll just start capturing on my Ethernet card. If I was doing Wi-Fi all day, well, I'd want to change that to my Wi-Fi. Okay? So that's really important to know that if you want to have a default, knock yourself out, set that. Now for packet slicing, this is a whole other topic. Packet slicing, if you want to capture just a portion of the frame or the packet, this can be because you want to save space on your drive. This could also be because legally you're not allowed to see the data. This can also be because the data is encrypted and you can never see it anyway, so what's the point of saving it? Those types of arguments. You can always double click on this snap length and guess what? You can define a different size other than default. So for example, the first 128 bytes, for example, that kind of thing. If you do want to capture stuff, you can actually control where you are capturing the file, and I'll show you this in a moment. You can actually define the name of the file, but then you can also tell it when you want it to stop. So you can say, hey, stop capturing after so many packets, so many files, so many kilobytes or megabytes and seconds and whatever. These are just stop triggers. But if you want the thing to capture for a while, that's called a ring buffer, you can actually set these. And using this top left box, you can actually find out, hey, I can actually give this thing a name and I can save 5 gigs of data and each file is 100 meg. Yeah, you can do that. Just be careful. When you have a lot of files, the tool literally stops and saves and then starts again. So every file has a small gap between them, if you will, right? If this is just Sally checking her email, it's not going to be a big deal. But if you're watching a server with a lot of data, then this may be a big deal, okay? Here's a little reference sheet for the most common capture filters that people like to see. You may be familiar with MAC address and IP address and port numbers, but there's some really cool ones. There's a port range, if you like, right? That's a cool one. And then the network filters. So if I want to capture everything on net 1.1.1.0, I can do that because that's my server farm and I don't need to add 50, 60 IPs in there. Now, you can also do capture filters for protocols. Now, this gets a little trickier. For example, HTTP is port 80. That sounds obvious, but guess what? You might not be using port 80 at work, or the application might not be using port 80. So please be careful when you use protocol filters. Whenever in doubt, please use a port filter, just to make sure you get what you think you got. And here's some examples of some common filters, right? Again, I'm not going to go through this with you in great detail. All right, so what I'm going to do now is we're going to kind of go straight to Wireshark. Let me just get that up. There you go. And I'm just going to capture some packets here. So I'm using that killer Ethernet gig, click, click. And obviously I get a whole bunch of stuff flying up on my screen. So the first thing you should be doing with Wireshark, and again, I'm going to just hit stop for a moment because I don't need to capture a bajillion packets to make the point. Right now, you probably can't read my screen very well. So at the very top toolbar, you've got 3 magnifying glasses, and the leftmost magnifying glass has a plus sign. So you can temporarily make the font a lot bigger, right? Temporarily, right? If you want it permanent, you can go into your preferences and change your font. But for now, this is a lot better, but everything's all mashed up. So if you want to resize it, I can manually go to each column if I want. But the easier way to handle it is to the right of those magnifying glasses is the resize icon. It's the last one on the right. If you click it, it automatically resizes everything for you. So that's just something to make you more comfortable with the tool. The other thing I would strongly encourage you to do is to get rid of these two panes, the middle pane and the bottom pane. Let's just name them real quick. This top one is called a packet list. The middle one is called the packet details. And the bottom one is called the packet bytes. So if I go to view, I'll see 3 check marks there. I can just click on bytes and it goes away. View, packet details, and it goes away. This helps you look for patterns. Protocol analysis is the art of finding a pattern, right? When you have 3 panes up, that's tough. When you want to investigate a packet, by all means, bring them back up again. That's not a problem. The other thing is the time. So the time resolution and the time format is a bit of an issue for me because most of the time I'm trying to document why it's slow. So I always suggest that people start with view, time display format, and I want this seconds since previously displayed packet. And that's good because later on if I ever have a display filter, then it'll apply to that, right? And there you go. So now I change this. So this is like the delta time for the people who knows the terminology. Delta time, the time between the packets, right? And then lastly, if I go to view, time display format, I want milliseconds. Milliseconds. And the reason why I say milliseconds is a really good reason for this, folks. And I've done a lot of testing with this, and the average Microsoft NDIS driver on the average system is only accurate to a millisecond. Okay, it may give you the timestamp to micro and nanos, but it's not accurate. So I don't want you guessing at those numbers. So this is as accurate as your machine's going to get. And people will say to me, how do I make it more accurate? Well, get a hardware-based capture tool, not a software-based capture tool. Okay. So there you go. So now we've got all of our stuff in there. So what other things do we want to do? Well, one thing you might want to do is actually give these IP addresses a name. So 74.125.142.127 is my Google Hangouts or YouTube audio stream, right? And video stream. So this is part of this broadcast, and I want it to say that. I want it to say YouTube, for example. Well, how do I do that? Well, if I just right-click on the IP address, I can go to Edit Resolve Name. When you do that, a very small bar appears at the top. So you really got to pay attention because it may not look like nothing happened, but it did. And right at the top, you'll see the IP address, 74.125, and the name, I'm just going to put YouTube. See that? Click OK. Mm-hmm. And it looks like it didn't work. So don't panic yet. Don't panic yet. Because by default, Wireshark is not going to resolve the network names. So you can go to View, Name Resolution, and then Resolve Network Addresses. Now we have the name. And this is also really important if you send screenshots to your vendors and you don't want to see the real public IP of your server. You can just call it SQL Server or Exchange Server or Firewall. They don't need to see the IP. You just need to know what their role is in the conversation. Okay? That's the first thing. The second thing you might want to do is some filtering. So for example, this stun packet that just popped up here. I might want all the stun packets. Well, one way to do a filter is to do this big, long, drawn-out process of going through statistics and conversations in UDP and find the IP and find the port number. No. The easiest way to do this now is right-click on any packet on your screen. And then what you're going to do is go to the conversation filter. And it's going to show you the options. Now, if it's a UDP protocol, it'll show you UDP. If it's TCP protocol, it's TCP. So you can see that it lets me filter on the Ethernet MAC address, the IP version 4, and the UDP. So I can choose which conversation filter I want to use. I'll just use UDP, for example. Boom, done. See that? So now all of a sudden you just right-click and you got a filter. You don't want your filter anymore. On the far right of the display filter, we got an X. Click that, and it all goes away. So what are some of the things we want to do? Well, I'm going to go start up another, well, let's do a display filter. I don't know if I can start up a new capture for this or not. I want to do a capture for just TCP packets. So I went up to the display filter and I typed TCP, and there's nothing there. So I'm going to start a brand new capture. And I'm simply going to start up my web browser of choice, and I'm just going to go to any old website. It doesn't matter where. And you can see that it's already coming up with all sorts of stuff on my screen. It doesn't take much to get one, right? And I'm going to hit stop for a moment. So what do we want to do here? Well, when you have TCP packets on your screen, one thing people want to know about is response time. So it's pretty tough to figure this out. I have a whole lot of SYN packets, and then I got a bunch of SYN-ACK packets. So again, I'm going to use that trick I just showed you a moment ago and do a TCP conversation filter. I'm going to right-click, conversation filter, TCP, bing, bada boom. And you can see now I've got my SYN and my SYN-ACK right beside each other. And because the time format is the packet since previously displayed packet, well, then that's what this represents, 44 milliseconds. So it took TCP 44 milliseconds to go from my machine to the server and from the server back. And now I have a round trip time, you see, 44 milliseconds. That's not a ping, right? Because ping can be unreliable or inconsistent. This is a real packet from a real PC to a real server across a real network going to a real application with real load. So this is as real as it gets. And now the other things that you're probably going to want to watch out for, and I'll be honest with you, I'm writing a bunch of articles on this exact topic, is the SYN packet. All of these options, what are we looking for? Why are we looking at them? This can explain why things are slow. So I'm going to give this to you in 3 minutes or less and just explain why I look at this one. For example, the MSS, the maximum segment size, that is the payload for TCP. How much data can TCP stuff in that segment? In the IP world, they call it an MTU. So router guys know MTU. Same thing. It's just MSS is for TCP. 1460 is the maximum, right? Skip the whole conversation about jumbo frames right now because it doesn't matter. So 1460 is the max. That's good. And then you can find out what the server's doing. In this case, 1418. It's a bit lower, and that's quite common when you want to support VPNs or pass-through, and they'll take a chunk off the top. So that's still pretty good. If I saw 256, if I saw 128, if I saw 512, I'd be a little bit more concerned. So there's something to look for right there. The other thing is the selective acknowledgements permitted, SAC-PERM. What does that mean? Well, in a nutshell, SAC-PERM means when we resend data, we can be very specific with exactly which ones we received. By doing so, the sender has to resend fewer packets. Therefore, the overall load on the network is less. So if everybody on the network had SAC permitted and all the servers had SAC permitted, and we did have some retransmissions, which is quite normal, then guess what? It's a more efficient retransmission algorithm. That's all. So see if people have SAC permitted. And if they don't have SAC permitted, it doesn't say SAC perm equals 0. It's not there because that's an option. All right? So I covered MSS, I covered SAC perm, and the last one, they go together, is the window size and the scaling option. So the window size is just how much data you can receive, right? And this thing, WS, is a scaling factor, and it tells me that my window size is not 65K, it's 65K multiplied by 256. All right, that's what it's telling me. So I got a huge window size. So why are we looking at this? Well, when some machines run out of gas, they start telling you that by implementing flow control and choking back the window size. So I've seen applications where the window size hits 0. It's literally called a 0 window, right? But I also noticed that when you have a window size less than your MSS, the machine behaves the same way. That's cool. That you need to know, right? So at some point I can show people display filters on how to find packets with a window size less than an MSS, but for now you can just visually look at that. So as you can see, capturing a few packets doesn't take too much. Looking at the SYN-ACK doesn't take too much. Looking at this response time, 44 milliseconds, it's right there staring at you. And you get a real quick baseline on how the PC's driver's configured and behaving, and the server's driver and stack is behaving. Now just be careful in the real world, you're probably not talking to the real server. You might be going through a proxy, a firewall, a NAT. And those devices can change this stuff, of course, but it doesn't matter. If you can just go look at these once in a while, you get more comfortable, then you'll be more curious as to what the other stuff means, right? For example, at the bottom, a reset. That's not a nice way to end a conversation. The polite way is saying fin, finito, finished, right? I don't see a fin here anywhere. Somebody just said, bang, punch right between the eyes. We're done talking, right? And that's what a lot of devices do. In this case, who did it? It's easy. Look at the source, which is me. I did it. 7.5 seconds later, nothing was going on, so I wanted to close the connection. So I'm a rude little bugger, and I punched him in the face. I said, I'm done with you. Okay? So as you see these patterns start to come up, you start to figure out what's going on. So I'm going to stop my screen share. Believe it or not, we actually chewed up 30 minutes already, Tim.
And you did a lot. I mean, you got a lot in there. It'll take people a few hours to, stop their head from spinning. But I mean, these are things that, like you pointed out early on, capturing data is experimental. Learn about your network, learn about your capabilities. And remember, every time a packet is touched by a device, it changes the timing. So you want to start out with the best timing possible, and the best timing is always directly connected. A tap is the best way. You don't want to add a bunch of extra delay or a bunch of filtering or grooming if you don't have to, okay? But, you know, as you point out, it's experimenting. It's actually fun. And, of course, in your classes, you teach that. It can be fun to go out there and plug in and see what the hell's going on. You know, it can be adventures. It's like going on a safari somewhere, you know? So,
well, I think what we're going to do, this little session, Tim, gave me a whole bunch of little ideas. If people enjoy this, you can always let me know with a thumbs up or a note in the YouTube or on Love My Tool. Just let me know if you like this or not. And I'll just spring off a whole bunch of 30-minute quick sessions that people can sit down and look at something specific with me. And I've got case studies and I've got examples, and I can go through more layers of the actual protocol if people like. But this is just the beginning, right? This is just, hey, let's go capture some stuff and let's save it and let's look at it later even, right? This is not a big process. This is not a time issue. This is an effort issue.
Yeah, and if once people start it, they'll enjoy it. Trust me, I've been there.
Yeah, me too.
You'll like it. Yeah, you'll like it. We promise you.
That's right. All right. Well, that was 30 minutes, Tim. So if you have any words of wisdom.
Nope, just play. Learn what is, to me, I tell people all the time, start with baselining. I don't care where you start, but start baselining. Look at, you know, your IP spread. What are normal IP addresses? Like last year with all the banks that got robbed at night, you know, through the internet, if anybody had taken any time at all to look, there was some aberrant IP addresses communicating directly with their control system for their outdoor ATMs. And if anybody had looked, they would have said, hey, that doesn't look right. But they didn't look. So, you know, that kind of left a scar. So learn what your baselining is. Learn what your network requires. Learn what's going on in your network. Actually, it's fun. And by the way, it's not illegal.
That's right. And I just, by the way, folks, I just showed you probably half a dozen baselines in that last little write-up about the last little speak I did versus the SYN-SYN-ACK and the SYN and the MSS, and those are all baselining values. So baselining is just a snapshot in time. So, folks, thanks for coming out, and thanks for coming out, Tim, and we'll see you at the next session. So have a good day, folks.
Everybody be blessed, take care, be safe, and do something positive.
Awesome. Bye, folks.
Bye.